perpendicular lines. Graph the following lines. So 2x plus 2 start at positive 2, and then I go up 1, 2 over 1, up 2 over 1, or down 2 back 1. So this is my blue line. And then we have y equals negative 1/2 x minus 4. I start at negative 4. 1, 2, 3, 4 on the y-axis. And then I go, if I go up 1, that's a positive direction, I would have to go backwards 2. Or I could have went down 1, right 2. But up 1, backwards 2, up 1, backwards 2. So I have these two lines. And what do we notice about them? What do we notice about their slopes? Well, first of all, do they ever intersect? Yes. We can see the point where they intersect, right? And the next question is, what do they have in common? Well, their slopes are definitely not the same. But what do we notice about their slopes? We have a slope of 2 and a slope, which is 2 over 1, right? So we're up 2 over 1. And we have a slope of negative 1 over 2. So what do you notice about those? Take a second to think about it. And what you should notice is two perpendicular lines have opposite reciprocal slopes, is what it's called. Opposite. Why does that look wrong? Opposite. Reciprocal slopes. For example, we already did that one, but let's say 1/3. What you're going to do is you flip it over to 3 over 1, and I switch the sign. So if I have negative 3/4, I'm going to flip it over and then change that sign. So now it's positive 4/3. If I have 1/2, I'm going to flip it over and change the sign, which this would just be 2. So you flip the fraction over and change it from a negative to a positive or a positive to a negative. So opposite reciprocal slopes. Write an equation of a perpendicular line that passes through 2, 4 and is perpendicular to the graph of this equation, y equals 1/3 x minus 1. So if it's perpendicular, all I need from this equation is that. I don't care anything about anything else. So I know this equation, m equals 1/3, but perpendicular to that wouldn't be 1/3. We'd flip it over, which would give us 3 over 1, and then I'm going to change the sign. So I need a slope of m equals negative 3. And I know it goes through this point, so we have a slope and a point slope formula. Y minus y1 equals m times x minus x1. So again, if we're going to switch it to slope-intercept form, we have to distribute that negative 3. Negative 3 times x, negative 3x. Negative 3 times negative 2, positive 6. We have to get y by itself. That's our goal in life, or in at least this section. Negative 3x plus 10. So here is an equation of a line that is perpendicular to y equals 1/3 x minus 1. You should, let's do one more together and then you'll try one. A line passes through 1/8 is perpendicular to the graph of y equals 2x plus 1. Here again, there's the slope. M is 2, and so to be perpendicular, it would be 2 over 1. This is 2 over 1. We flip it over and change the slope. We need a slope of negative 1/2. So y minus ry equals negative 1/2 the slope times x minus the x we're given. Distribute your 1/2. Negative 1/2 times negative 1 is positive 1/2. And we have to add 8. You get y equals negative 1/2 x plus 8.5. You could have written 8.5 different. You could have written plus 16 over 2, excuse me, 17 over 2. If you left it as a fraction, you could have written 8.5, but you should still have that same slope. You try this one, passing through 4, -6, and is perpendicular to this. This is going to be a tricky one, so put me on pause and give this one a try. Okay. You should have realized that you had to rearrange it to be y equals mx plus b so you could get the slope. And we get the equation rewritten. You get y equals the slope of 2x minus 4. The slope is 2. We need a slope of -1/2 then. So I take the slope and the point they're given, and I put it into equation y minus y1 equals -1/2 x minus x1. I simplify to get slope intercept form, and you should get y equals -1/2 x minus 4. Are the graphs of 4y minus 5x plus 12 and 4/5 x minus 8 parallel, perpendicular, or neither? Literally all you have to do is look at their slopes. The problem is this one is not in slope form or slope intercept form, so I don't know what that is. So to get it, I need y equals something. So I divide by 4. And you get y equals -5/4 x. Hey, by the way, direct variation, because there's no plus or minus at the end. So that is something we're reviewing for. We talked about direct variations. They always go through 0, 0. So my y-intercept here is 0. But anyway, here's the slope, -5/4. The other slope is 4/5. Is that parallel? Absolutely not. They're not the same. Is it perpendicular? Well, if you flip this over, you would put 4 over -5, and then you would change the sign. So it would be 4/5, which is what they are. So these are perpendicular. And why? Because the slopes are opposite reciprocals. Are these parallel, perpendicular, or neither? Again, we look at the slopes. I have one slope here, 3/4. You have to get this into the right format. Don't make monkey cubes. You get -3y equals -4x, a monkey pines, plus 9. Divide by -3 because I have to get y by itself to get the slope. I have y equals -4 divided by -3, which is 4/3, positive, and then -3. So here is this slope. So I have a slope of 3/4 and 4/3. Definitely not parallel. Are they perpendicular? They are flipped, so they're reciprocals, but they're not opposite reciprocals, so these are neither. What would I have to do to make them opposite reciprocals? We would have needed one of these to be negative. One negative and one positive, and they're not. So since they're both positive, then they're neither. And this one, we already have this -1/6. Here, again, I have to get y by itself. It's not going to be too hard here. I just have to divide out everything by 6. I get y equals -1/6 x plus 1. -1/6, -1/6, they are symbol for parallel. Parallel y. Slopes are congruent or equal. So the lines are parallel. All right, a path for the new city park will connect a park entrance to Main Street. The path should be perpendicular to Main Street. What's the equation that represents a path? Well, again, I need to know the slope of Main Street, and if it's still the same slope as it was 2 days ago or yesterday, it's a rise of 2 and a run of 1. So this has a slope of 2. If I want it to be perpendicular to Main Street, I want it to go perpendicular to Main Street, I need to have a slope not of 2. If m is 2 and I want perpendicular to that, I have to flip it over and switch it. So I need m to be -1/2 And I know it goes through the point 0 over 4 up at the park entrance. Y minus y1 equals negative 1/2 x minus x1. Y minus 4 equals negative 1/2 x. And we have to get y by itself. And the equation of the line for a perpendicular would be y equals negative 1/2 x plus 4. That would be the path. That is all for this section. Yay!